Thanks for coming. This talk is High Performance Java EE with JCache and CDI. I'm Steve Millidge. I'm the founder of Pyara. Has anyone heard of Pyara? Yeah, that's good, because we've been going a year and a bit. So Pyara is derived from Glassfish Server, open source. So essentially, we take Glassfish Server source code, we provide enhancements and support for Glassfish Server source. So that's partially relevant to this talk. So later today, I have another talk in this room, 2 talks from now. And it's going to be on Java EE microservices platforms, which is the best. And that is related a little bit to this. Everybody has to talk microservices now. The only way you get if you get one a conference speech, you put the word microservices in the title, and then someone will give you a speech. So we're going to talk a little bit about microservices, but maybe about the consequences of microservices. But my talk later will look at Pyara Micro, Spring Boot, and Wildfire Swarm. So this is the Wikipedia definition of microservice, and I quite like it because it's simple and it hasn't got loads of hype in it. So essentially, microservices is an architectural style. So we're talking about architecture here, not programming, not technologies, in which you take a complex application, sometimes called a monolith, which is obviously a term deliberately chosen to be derogatory by people who propose microservices. Now, I've got nothing against microservices, as we'll see. But you basically take an application and you compose it into small independent processes that communicate with each other using language agnostic APIs. So what that means technologically is it typically uses REST. Okay? And this will solve all your application architectural problems. So as you can probably see, I'm going grey. I've been here many years in this industry. And one of the things that you cannot avoid when you start splitting things up is there's some very old rules and fallacies of distributed computing. Okay, and we're going to hit these when we do microservices. So the first one is the network is reliable. Obviously, everyone codes systems for sunny day scenarios. Okay, system's up on the other side. I call it, get a result. Bingo, everything works. Obviously, the network isn't reliable. That system that you need to call may not be up, so therefore, compared to a monolithic application, you have to put in a lot of fault tolerance. And the key one we're going to be talking about today is number 2, and that is that latency is 0. Okay? If you go from a monolithic application where you have an in-process call, then latency is probably effectively 0, because you're in the same process. However, as soon as you split those up into multiple remote calls, then latency is no longer 0. Latency is dependent on many factors, which we'll look at. So latency is essentially the time taken, the time delay from invoking an operation and getting a result. Well, actually, that's not correct. From invoking an operation, that operation actually starting. Okay, getting a result may depend on the processing time of the operation itself, which isn't necessarily latency. The other ones are pretty obvious. Bandwidth is infinite. None of us live on a shared network, obviously. Network is secure. Topology doesn't change. There's only one administrator. Transport costs and effectively marshalling costs, serializing, deserializing data to JSON, for instance, has 0 cost. But as we're doing a talk on JCache, the only one we're really interested in at the minute is the latency is 0, 1. So the big danger on any architectural, I nearly said the word paradigm there, in any architectural model like microservices is latency. Okay? Latency is the classic problem or cause of this worked fast on my machine sort of mentality. Okay? It all works fine when it's running on your laptop, and it doesn't work fine when you spread it across 3 data centers around the world. And that's latency. So let's have a little explore of latency. So these are some figures, which I sort of Googled around on the internet for, so don't crucify me if they're incorrect. Effectively, you've got DRAM, so RAM on your machine. There's a latency of around tens of nanoseconds to access data in main memory. Not on cache, but actually in main RAM. And you can get various figures that sort of work around throughput of memory is around 120 to 250 gigabytes per second. Obviously, it depends whether you're on DDR3, DDR4, or fancy ones beyond that. SSDs have about a 0.1 millisecond access time latency. They can shift about 600 megabytes a second. If you're on SATA 3, a little bit maybe more on InfiniBand. And then you've got hard disks, or spinning rust, as they like derogatory called. They've probably got a seek time of maybe around 10 milliseconds and a couple hundred megabytes per second. And then when you go on network, so on a 1 gigabit Ethernet, which is, obviously you could go to 10 or 100. However, on a fairly standard 1 gigabit Ethernet, a local call, which effectively means within your machine, using the network stack, will probably typically be in the microseconds sort of range. Okay, something on the same LAN segment is maybe 300 microseconds. Once you start crossing a switch, you're probably into a few milliseconds. And then within the UK, we're talking about tens of milliseconds, and then UK to US, 100 milliseconds. So obviously, the latency gets greater as you move things further apart. And the transfer rate of a typical gigabit Ethernet is 25 to 30 megabytes a second if you get all that yourself, obviously, and there's nothing else running on the network. So the point of putting these up there is essentially memory is fast. Okay? Memory is fast. Everything else is slow. Orders of magnitude slower. So essentially, caching cures latency. Okay? The only reason to use JCache or any API that does caching is for latency. If you have no latency, then you don't need a cache. It's just going to complicate things. I mean, that's true from right down to CPU caches, right up to massive distributed caches like we'll see in JCache or Redis or anything those sort of things. Caching is there for latency. There's no other purpose for caching in your architecture, potentially. So let's explore the API. So I had to do 2 talks for this. My colleague dropped out of the second one, which is why I had to pick it up. So I thought, okay, I need something to test both and demonstrate both JCache and microservices. So I picked an application. The application is going to be a RESTful web service because we're doing microservices. And I thought, I need some data. Okay, so I did a search on the internet. The UK is quite good. The UK government, it has something called opendata.gov, where they shove loads of data on the internet and expect you to do something with it. So one of the things I picked was Roadworks data, because I thought that was quite interesting. So I've taken Roadworks data, and what I've got coded up is a RESTful web service where you can search for what roadworks there are on various roads in the UK, because I knew that would be fascinating to an audience in Gothenburg. So I didn't actually look. I should have looked to see if there was any Swedish equivalent to that data. So the web service I'm going to show is pretty standard. We've got a MySQL database. I ingest all their data into a MySQL database. I have a RESTful microservice to be trendy. And ignore that bit, because that's where I got the data from. And we have a RESTful interface where /roadworks gives you all roadworks. And the other one we'll look at is /roadworks/road, which will give you all for a specific road. And I'm going to run this on BioMicro. Okay, if you want to know more about BioMicro, come to my next talk. But essentially, it's a Java EE runtime derived from Glassfish that will run WAR files on the command line, like that. So it's suitable to be packaged up in, say, a Docker container or something. Like I say, later today, we'll compare Spring Boot Wildfly and Wildfly Swarm and BioMicro. But one thing it does do for this talk is it embeds JCache. So basically, I'll take you through the code of this. on this massive resolution screen. If NetBeans is going to refresh itself. Okay, I haven't got much screen real estate to work with. Let's start at the bottom. So this is basically a standard Java EE application written for microservices. So we have a entity bean. Okay, everyone familiar with entity beans? Everyone use JPA. Even if you use Spring, you'll be using JPA probably, unless you still hold out and hibernate, which is just JPA. So you have an entity, we have a table, and there's lots of fields which are defined by the UK government. I have a EJB, which is a facade for that. So if you have never written EJBs for a long time, it probably won't look anything like you used to. So effectively, this is an EJB service. The reason I'm using it, it gives me transaction boundaries. So it's a stateless EJB. Here we inject the entity manager, and we have a find all, find by ID, and a find by road, which uses the entity manager named query, which will be defined on the work here. We got find by road, which is select P from planned works where P planned works P where P.road equals road. Okay, so that's my session bean. It's just a facade around the entity manager, and then I have a RESTful web service which has the path of roadworks. It injects the EJB, and we have a get, which basically calls find all method on the EJB. And we have another get, which has /road/name, which calls the find by road method on the EJB. Okay, does that make sense to everyone? So that's pretty standard Java E7 type web service. So we are going to run that. If I can find where I'm supposed to be running it. Right, so I have a BioMicro jar. So basically I'm going to run it using BioMicro. So that'll essentially run my WAR file. Oops, I have another one running. Hang on. Always clean your machine up before you do a demo. I have another process running. Which I need to kill. Which I can't find. Which one of these shells is it running? Apologies for this. I need to find out which one it is without killing off my NetBeans. They both look like NetBeans to me. Ah, it'll be that one. Okay. Oop. 6357. That's better. Okay. So, problem with BioMicro is you can run lots of them on the machine. So if I go back to where I was going to run it, basically there's something else bound to port 8080, and it's starting to start out with port 8080. Okay. So it's running now. I've got BioMicro ready in. See, I've lost my battery. Never mind. So we should be able to see this work. So basically, there is all the roadworks in the UK as an XML file, which I can. So if I put in a road, I shall put in A419 because that'll be meaningful to everybody here. That has 2 roadworks on it. Okay, it's quite close to my house. It has carriageway repairs on Merlin Way in Swindon, which is an exciting part of Britain if you ever go there. It has what's called a magic roundabout, which is a roundabout with roundabouts round it. So basically, we can see that web service basically works. What I need to do is introduce some latency so I can add in some JCache into that. So if I kill that off, so I remember. So I'm just going to be very crude and take my RESTful web service on the road. I'm going to put a sleep in there just to demonstrate latency. Oh, I don't want to do that, do I? Struggling with screen resolution here, I must admit. Okay, so let's add some can't even remember how to code now. Red.sleep, 5 seconds. Let's put a surround with catch. Okay, let's rebuild it. So that will build, and I'll rerun it. So basically just demonstrating some latency. So imagine that was really going off to the highways agency in the UK. And over this Wi-Fi, that would give us some significant latency. So if I run this now, yeah, we can see that it takes some seconds to return. I can actually make that a bit smaller. Okay, so we've got latency in our service. So let's try and look at caching the result from this using JCache. So what I'm going to do is I'm going to use 12 characters, which should solve our problem. So JCache defines a bunch of CDI annotations, one which is called cache result. So if I now rebuild that again, I'll just kill off my service. Okay. So if I refresh, start it up. So if I refresh that the first time, I'm going to have the same problem. It's going to hit latency. And the second time, basically comes back straight away. Okay? So just by adding these 12 characters to our code, we've speeded it up substantially. So the question is what just happened, essentially. Okay? So what we did there is we've used JCache. Okay? JCache is a standard Java API for caching. And it has a normal API, so you can use it through normal Java, but it also has a CDI binding. Okay, is everyone familiar with CDI? Okay, CDI is a standard dependency injection framework for Java EE. Okay, and part of it will provide interceptors. So these annotations are effectively wrap the method call. And JCache is supported by many different providers: EHCache, Coherence, InfiniSpan, Apache Ignite, and Hazelcast. BioMicro has built into it Hazelcast. So basic concepts of JCache are: is you have a caching provider, which is a product like Hazelcast, Apache Ignite. You have a cache manager in the API, which basically creates caches. You have a cache, and a cache is essentially a big hash map. It's got put and get based on keys, so key values. And Hazelcast is a big distributed hash map, effectively. So, like I've just said. So what cache result did, so when we went into that code and just added cache result onto our method definition, that was a CDI interceptor. So an interceptor basically, before it invokes your method, will invoke the interceptor, and the interceptor gets a chance to do stuff. Okay, and what our interceptor does is it gets a caching manager from the caching provider. It creates a cache name, and it bases that on your method. It takes your method and munges the name of it and munges all the parameters together and gives you a name of a cache. It looks that up in the cache manager. If it can't find it, it creates it. It then takes all your method values, parameter values, and it creates a cache key. And then it looks in the cache before it actually invokes your method based on that key. And if it finds something, it actually gives you the result straight out of the cache and never invokes your code at all. Okay? If it doesn't find anything, it invokes your code, takes the result from that code, adds it into a key, and puts it in the cache. Okay? Effectively caching the method result of the method call. So effectively you are removing all this boilerplate code that if you use a JCache API you would need to write. It's actually a lot longer than that. Okay, so basically interceptors gets the caching provider, gets a cache manager, creates a new configuration, sets the configuration of the cache, creates the cache, creates a key, and then caches the result of your method call. But okay, so CDI interceptors give you a massive simplification of that. So there are other CDI annotations as well. Is there any questions on that before I move on to these? No? Okay. So I'm going to look at a totally different thing. So basically, CDI provides all the things you could probably want to do in the simplest case with your cache. So you can cache the result of a method call. You can put a specific method parameter into the cache. You can remove something from the cache, or you can remove all entries from the cache just through annotations. And I've got a slightly different project to demonstrate this. So, which is basically showing you how you could build a distributed key value store for JSON in like no code whatsoever. Or some code, but not a lot of code. So I should get rid of that. So all this code is basically, there's a slide at the end, but it's all on GitHub. So if you want to play with it, you can. So I have another project here called REST JCache. It essentially has one cache resource. So it has one RESTful resource. And So essentially, we have another RESTful web service. Path is cache. We call the context. We have a get method, which does the cache result is there. So part of cache result, you can pass in a cache name, rather than it creating like a synthetic name based on your method, which wouldn't be very useful. It's only useful for your method. You can actually give it a standard name, and then all ones will use the same cache. So we've got a cache result there. So that will cache the result of this method, and that has a key. So it basically looks something up in the cache and cache the result. We have put, where it uses the same cache. You can give it a key. Basically, you have an annotation called cache key, and that says that is going to be the key that I use in my cache when I put something into the cache. There's an annotation cache value, which is also basically going to say that's the value that I'm going to put in that cache. So that annotations of cache put with cache key and cache value will mean that it will put an object into the cache. And we have a delete, which is cache remove, and that has a query parameter called key. Okay. So I'm going to basically build that. That's all there is to that application. And this, using JCache Annotations, is going to give us, and BioMicro and Hazelcast is going to give us a distributed key value store. So I clean and build that. I need to now find the right console. One of these had tabs on once upon a time. And on this resolution, I can't see the tabs. So I should have built that application. We can see that it's at, we can possibly see that the application is on that path. Basically, there's the WAR file. So if I run that, in the wrong window. Right. So basically, I run Java minus Java BioMicro minus deploy, and I find the path that's on here. That will basically boot up that RESTful web service. And we should be able to use curl, if I can see it. Okay, so this will give basically this curl command. Can everyone clear that? Get rid of that. Okay, so this basically this curl command here will basically get the key, and basically it produced hello world. Not the best output, but you can see that that's produced hello world, which was the default value. So I'm going to use another curl to put. So this curl is basically going to put some data in using the put on the rest. I'm going to put in jDays test data. Okay, so I got a 204 back. If I do the get again, we can see we got jDays test data. Right, so my RESTful web service is working. I can update the data. Okay, not only that, if I find another window, I could open a tab, do the same again. I'm going to use another parameter to BioMicro, which is auto-bind HTTP, which means it'll just find the next available port. There. So if I deploy another copy of that WAR file, basically we're using JCache underneath. So JCache is a distributed cache, so it will auto cluster and will auto share the data. So you can see that it's popped up members. I'll go back to it in a sec. So it's basically automatically found that there is another cluster member already running, and it's joined them together to form a distributed cache. The upshot of which is if I go back to my curl, actually change that, not that one, do a get this time on 8081, you'll see that I get the same data from the second node as well as I got on the first node. So basically they are now a distributed key value store, so which is pretty cool. So just using the annotations, you can build quite complicated applications that are using the underlying persistence of the caching provider. So Payara itself has a number of other CDI extensions which aren't standard. So all the ones I've shown you so far are standard JSR 107 annotations. We've added a couple more, which are basically just to inject a cache and to inject a cache manager. We're working with a Java E8 team to try and get something similar to this in Java EE8, because currently you'd have to look them up through the API. So JCache doesn't just give you a key value store. It has some other capabilities which are more data grid oriented. So one of them is entry processes. So imagine that you have a cache and it consists of 4 nodes. And there's some data on that cache. So basically we have 4 objects, which is what these circles are, these colored circles. And then what entry processes are for basic doing computations across all that in-memory data. So you imagine data in memory is fast. So imagine instead of our trivial situation where we have one key and data, we've got, say, many machines with hundreds of gigabytes of RAM, and we stack that up with data in memory, so hundreds of gigs of data, for instance. So for a data grid like JCache, it basically has high availability by storing a replica. So if we have a blue object here, it would actually have a replica of a blue object on another node. It only has, by default, it'll have 1 replica. So that means the more nodes you add, the more memory that you have available to you. It scales. So add 4 more nodes, you have twice as much storage available across your data grid. But however, to do a get with all that data, to process it would mean you'd have to pull it all across the network to where your processing was, and that would be expensive because of latency. So what JCache also brings in is the concept of entry processes. So in an entry processor, if you want to do some processing of data, what it actually does is you specify the set of keys that you want to process the data across, and it will effectively serialize the processing across the network, run it locally on the local keys, which is much faster because your processing code is probably much smaller than the data that you would have to drag it across if you were going to bring it all and run it all on this node. Also, it means the data you're processing doesn't have to fit in memory. And it brings that result back to where you did the processing as it's basically a set of maps of results. So in addition to like key value store, you also get a compute grid as well. The third major feature that you get in JSR 107 JCache is something called cache entry listeners. So what that basically says is that you as an application, you register for keys that you're interested in. So classic example is a stock, as it always is. Finance, you register interest in a stock key, so like a ticker symbol or something. Any updates that you get, you then get notified. So for example, if a new object came into the cache, right over there, basically you would get an event called back to your cache listener, which would then allow you to do whatever you wanted to that object. If it's a new one, you'll just get the object value. If it's changed, you'll get the previous and the current value. And that actually gives you a lot of data grid capabilities to build complex event type driven applications. So I haven't got any code for those, but they're basically extra things that you get in JCache over and above your caching capabilities or your distributed key value store. So, just to summarize, you only really want to use caching if you've got a latency problem. Okay, don't throw caching into your application if there's if there's no performance issue that you're trying to solve, unless you go into the more the complicated cases of computation on the grid or event listeners. So JCache itself is a standard API. So it's defined by JSR 107. Like I say, there are multiple providers that you can use. And the way it works is in your API, you just get a caching provider, and it will basically use a Java JDK service loaders to work out which caching providers are available, and it will give you that through JSR 107. So you don't need to tie yourself to Hazelcast or Coherence or JCache. You can just use a standard API. So Pyara itself has it built in, and I'm sure the others will do the same. Okay, so in our case, Hazelcast has given us our caching provider. Hazelcast is a big distributed hash map. It provides performance, resilience, scalability. But you also get in JCache, you will get those data grid capabilities. So you get compute and events on top of your big distributed hash map. So if you want any more information, I've deliberately put an information slide in because the slides will obviously come out. So the spec is available there. There's a URLs there to Pyara. The code for the RESTful service for the roadworks is there. It's jDays 2016. There's other examples. The RESTful JCache code is there on GitHub. It's one of the Pyara examples, and there's some others as well on there if you want to play with this stuff. Okay, I think that's me close to out of time. Any questions? Yes, but not in a standard way. So there are obviously all the providers provide like custom bits. So expiration is essentially a custom piece of code. It would be on a per item basis. Okay, you can blow away the whole cache. Sorry? Yeah, I mean, most of the cache providers provide that capability, but you need to hook. Expiration, for some reason, wasn't standardized. I don't think so. And what we do have standardized is cache loaders and cache writers. So if you want to have a back-end store, that is standardized. So, for example, if you want it expired, and then you want it to automatically pull something from a database, then there's a cache loaders defined that you could write to a standard API, which would do that bit for you. Yep. Yeah, it's completed. No. I was on the second expert group. It wasn't really forever. Basically, what happens is it started like 10 years ago, and then it just completely stopped. And then it was resurrected like 2 or 3 years ago. It's been out now for about 18 months. So it is final. It's been final for quite a while. And as like I say, all those providers are built to the final API. What it did do is miss Java E7. So it's not in there. It's actually, to be fair, it's actually an SE spec, not a Java EE spec as such. So it should be usable in other things. Okay. Thank you.